Hi guys, welcome to this video where we're going to look at primarily at column vectors, but it's also quite a nice introduction into vectors in general. So you've probably come across the word vectors. I know for a fact we've spoken about it in maths when we're talking about things like velocity, acceleration. A vector is something that has got both magnitude and also direction. So again, in physics you've probably spoken about the fact that velocity is a vector because it has both a magnitude, how fast something's going, and also a direction, where it's going to the left, to the right, up or down. So column vectors are the same. We've actually come across column vectors before. We did it very briefly, but it does form a big part of translations. So if you remember, if we want to move a shape from one point to another, we describe it using a vector. So we draw some quite big brackets and we're going to put some numbers in a column. So there's a number on the top, I'll just call that A, and a number on the bottom, which I'll call B. So the number on the top tells you how far either to the left or to the right you go. I appreciate I've just said those the wrong way around. And the number on the bottom tells you how far up or down this vector will be moving. Okay, so just be aware that to the right is the positive direction and left is the negative direction. And this one's a little bit easier to remember, I think. The positive direction for your second part is going to be up and the negative direction will be down. So for example, if I just give you a few examples of a vector, if I said vector 1, 2, that means a movement of 1 to the right and 2 up. Okay, if I had a vector of 3 minus 4, I'd be moving 3 right and 4 down. And finally, if I had minus 2 minus 5, I'd be moving 2 left and 5 down. Okay, so it just describes a movement. Okay, it's just a shorthand for saying I'm moving 1 right and 2 up. So you may come across questions where a vector is defined. So in the exam it will print all of these in bold. They might just label them. Chances are they'll just go through the alphabet. The exam will label them with a bold letter. Okay, so I've just tried to do it there. Obviously it's really hard to do that in pen. So when you're writing them, I would just make it really clear. We tend to just underline our vector. To make it really clear, it's a vector. It's not just a random letter that's floating around. It's not an algebraic term, it's a vector. So we would underline it. So we could say a vector A is, let's go for one I've already used, 1, 2, and a vector B is going to be 3 minus 4. So there's a couple of basic operations you can do to these vectors. So you could say, well, or a question could ask you, well, what is 2 times vector A? So all you would have to do is multiply each part of that vector by 2. Okay, so that is going to give you vector 2, 4. Okay, I think lots of you probably, I know looking at your marks when we hadn't actually done this, lots of you were happy with that idea. Lots of you managed to get all the marks for a question that was essentially that. You could also be asked to add vectors together. So you could be asked to do A plus B. So vector A plus vector B is going to be 1 and 2 plus 3, and then I'm going to add on minus 4. Okay, so that is simply going to be 1 plus 3 is 4, 2 plus minus 4 will be minus 2. So you can do some basic arithmetic with vectors, and that is probably going to form the first part of a question. Now, just remember, vectors are a movement in at any point. Okay, so they're not really the same as coordinates. Coordinates refer to very specific points. This movement, this position vector, this movement can happen at any point. So if I think about vector A, it means I'm simply moving 1 right and 2 up. So actually what I'm going to do next to these vectors, there's a reason I've used squared paper for this, is draw that vector in, because some questions may have this. So a visual representation of that vector, if I'm starting from that point, would be me moving 1 square right and 2 squares up. Okay, I'm just going to connect them like so. I'm also going to make it really clear what direction they're going in with a little arrow, and I'm going to label it. That is how questions may appear. So it's really clearly taking me 1 square right and 2 squares up. I'm going to do a visual representation of this vector as well. So let's say that is my starting point. I'm moving 1, 2, 3 squares right and 1, 2, 3, 4 squares down. I'm just going to join those up and label it. So those are just visual representations of the vectors. Now you can apply vectors at any point and you can apply them together. So this new vector I have created there is the combined effect of a movement 1 to the right and 2 up, followed by a movement 3 to the right and 4 down. So what I'm actually going to do is just draw these two vectors together. So I'm going to start off with vector A, so that is 1 to the right and 2 up, and I'm going to label that vector A, and then I'm going to follow vector B. I'm going to apply vector B. I'm going to move 3 to the right, 1, 2, 3, and 4 down, 1, 2, 3, 4 down, and join those up. Okay, now the only issue with doing vectors kind of one-to-one size is that it's quite tight when you use small numbers. But what I want us to think about is, instead of moving from here up and down, what is the most direct route I could get from my starting point to my end point? If I join those up, what have I actually done? Well, I've moved 1, 2, 3, 4 to the right, and I've moved 1, 2 down. So that movement vector, the combination of A and B, is 4 minus 2. But we've seen that vector already up here. Okay, so what I've said here is I've added together vector A and vector B to give me 4 minus 2. So I've represented it visually as well as in a column. So I think that is a very basic introduction to vectors. I'm going to go into a little bit more detail in the next video. What I would say though, I'm just going to give you a few vectors, a few calculations to do. So I'm just going to write a few example vectors. So let's have some new vectors. Let's go, vector A is 2 minus 5. Vector B is 1, 3. Vector C is, let's go 0, 2. So just a few questions maybe for you to have a go at yourself. Question 1, I'd like you to calculate 3 lots of vector B. Question 2, I'd like you to work out negative 2 lots of vector C. Question 3, let's go for vector A plus vector B, and then part 4, let's go for vector A take away C. Maybe pause the video now and I'll give you the answers in a moment. Okay, so I'm just going to go through those answers. 3 lots of vector B is going to be 3, 9. Minus 2 lots of vector C is going to be 0, minus 4. Vector A plus vector B is going to be 3, minus 2. And vector A take away C is going to be 2, minus 7. Okay, the magnitude of vectors is really important. We will look at that in more detail in our next video. So keep your eyes out, guys. It will be uploaded very shortly.